Welcome, my name is Risho Kejwi, and welcome to this series of Mindset Kabanga educator videos for grade 5 mathematics. Mental calculations are dependent on an individual's ability to perform any one of the 4 operations in their head without resorting to pen and paper. They are skills that enable us to perform these operations, and out of necessity, your learners need to be taught methods that will satisfy this need for a lifetime. As your learners acquire these skills, they might even change some of your methods to suit their own understanding. Your job as their teacher is to equip them with some well-known methods as a starting point so that they are empowered to think mathematically and do calculations in their own heads when the need arises. There are many methods we can use to add 2 3-digit numbers together. For example, using expanded notation or accumulating a series of totals compensation. What is important is that when you do have to add numbers together mentally, we do not naturally place them in columns, one underneath the other. Draw a line and then start adding the units and then the tens. Sometimes we round off the number if we want to estimate the answer. In this episode, we will look at 2 methods of adding 2 numbers together mentally, namely compensation and expanded notation. You will see that both methods use numbers that have zeros. The answers will be the same and they will be exact. The word compensate is linked to the idea that we take an amount from one of the numbers and we give the same amount to the other number before we add. The word expanded is linked to the idea that the numbers are partitioned or stretched out with parts of addition signs before we add. In studio with me today is Elizabeth Larduke. Welcome.
Thank you.
Her experience includes primary school teaching, high school teaching, and many years of teacher training institution with focus on the intermediate and senior phase. Liz, why do we have to teach primary school learners the skills of adding numbers mentally?
From an early age, the children should learn to add mentally, because what we're doing in the classroom is preparing the children for life outside the classroom. And in real life, we don't usually carry around a pencil and paper with us to do calculations. So we need to do them quickly in our heads.
Do you have a couple of examples for us?
Well, for example, if you have 2 children going shopping and each child has an amount of money and they decide that if they put their money together, they would be able to spend it more effectively. They would then add the amount of money mentally. If they couldn't do that, they would have to count it up, which would take quite a long time.
Besides adding numbers mentally, because maybe one needs to calculate and get an answer quickly, or maybe we don't have a pen and paper at hand, so you can calculate and get the answer. Why do you think it's so important for primary school learners to calculate mentally, like you stated in your assessment standards of grade 4, 5, and 6?
Well, when the learner learns to do the addition algorithm on paper, there is the concept of carrying, which causes a lot of problems. Now, if a learner adds 2 numbers together mentally, that problem is solved quite naturally. If I give an example, if we add the numbers 54 plus 37, we add the units together, we get 4 plus 7 is 11, which is 110 plus 1. And that 10 is added to the 30 plus the 50.
Sure.
Which makes 90 plus the 1. So they encounter it quite naturally in mental arithmetic, whereas on paper it looks very foreign.
Then what do you mean when you say the learners can construct their own methods?
every person is an individual, and as a result, every person thinks differently. Now, if I had to add the 54 plus 37 in my head, I personally would add 54 plus 30, which gives me 84, plus 7, which gives me 91. Another person might add 50 plus 30 is 80, 4 plus 7 is 11, and also get 91. So when learners learn mathematical ideas and concepts, they have to make them their own. And by making them their own, they also use different methods to arrive at an answer.
Thank you very much for your time.
Thank you.
Let's go over to a classroom, but remember the key points to look out for in the classroom study. You have heard our expert explaining why learners in the intermediate phase need to do mathematical calculation mentally. They will find themselves having to add numbers outside the classroom, and for this purpose, they can use non-standard procedures for doing so. In the classroom, notice how the teacher introduces the methods using the same two-digit numbers. The learners can participate with knowledge they already have from their place value experience. The exercise is given as a bingo game so that mental mathematics is a fun game to experience. The teacher lets the learners choose to play the game with any method that suits them.
Can you think of an occasion when you had to add 2 or 3 digit numbers in your head without using any pen or paper? Fatima?
When I go to the shop, then we have to add the prices and see how much we have to pay.
That's good. So you can add numbers in your head, or you can subtract numbers in your head, or you can multiply or divide numbers in your head. So when you are doing that, we call that mental mathematics, because you are working mentally in your head. Now, you are given this problem on the board. I have 64 bins and my friend has 28 bins. How many bins altogether? And you are asked to work this sum out in your head. So there's different ways of doing this sum, but I'm only going to show you one easy way of doing this sum mentally in your head. And we call that way expanded notation. When we are doing this, I have to ask myself what goes on in my head. So my head tells me I have to add 64 plus 28. Now, if we are doing expanded notation, we have to change these numbers and write them in expanded notation using the tens and the units. So how many tens are there from this number? There is 6 tens plus how many units? 4. 4 units plus how many tens? 2 tens. And how many units? 8. So I've written the units in yellow and I've written the tens in orange. So now in my head, I have to add the tens together and the units together. So I will say 60 plus 20. 60 plus 20. And what do I get? 80. And I have to say 4 plus 8. And what do I get? 12. Now 12, I can still write it as tens and units. So it will be 10 plus 2. And this 10, I can add it to the tens as well. Now, what is 80 plus 10? 90. And and there's 2 units. So what is my answer? 92. Okay, now I want you to copy this sum down the way it is, and I'm going to give you one sum that you're going to do on your own on that other side. You can start. Everybody is finished. So what is the answer? All of you?
133.
Yes, that's good. It's 133. But I want to see how you got the answer. So let's do this sum together. So what was the first thing that went into your mind? So you said 57 plus 76, and you said it will be 50 plus
7 plus 70 plus 6.
And what did you do next? You added the tens together. So what are we writing?
30 plus 70.
And on this side?
7 plus 6.
And what is 50 plus 70?
120.
And what is 7 plus 6?
13.
Now let's write 13 in expanded notation. What is the answer?
10 plus 3.
Now let's add the 10 to the other 10s. What is 120? And what is 120 plus 10?
130.
Plus the 3 from the units.
133.
You have seen learners adding 2-digit numbers in their heads. This is a skill that has embedded itself and can be called upon at any time. When you feel they are ready, perhaps you can challenge them with the addition of a 2-digit number added to a 3-digit number. Well, that's all we have time for today. Don't forget to join us next time. Until then, Risho Ketri, goodbye.